So welcome to topic 4, stats and probability. So we're starting the probability basics. I'm going to assume that you remember little to nothing of things that you were maybe taught in middle school, but basic things, right? So sample space is list everything that you can have. So for example, if you flip a coin, you can either have heads or you can have tails, okay? If you roll a dice, you can have, if it's a standard dice, it's 1, 2, 3, 4, 5, and 6 that you can get, right? That's everything that can happen. You won't be able to get a clown on a dice because there are no clowns, right? It's just numbers 1 through 6. Okay. If you flip 2 coins, so one way of doing this is some of you might be able to do this a little bit easier than others, but if you have heads here, if you have, I'll just say 1 coin here and another coin here, what you could do is see where they like meet, right? So this outcome right here, this point is going to be heads, comma, heads, right? This outcome right here is going to be heads, comma, tails. The order of it, in this case, doesn't matter. And then over here, I'm going to have tails, comma, heads. And then in this one right here, I have tails, comma, tails. Okay. So this is my sample space if I have 2 points. Notice what I just did, right? I put them into these curly brackets. It's called a set. Okay, this is my sample space. All right, so things that you need to know. Probability of an event. The good thing about probability is it can predict what's going to happen in the future. The probability is always going to be between 0 and 1 as a decimal, and that's the same thing as between 0 and 100%. And we're going to talk about percent out of 100 in a bit. The probability definition is given to you in your formula booklet, so you don't need to memorize it, but it's pretty straightforward, right? The probability of A happening is you put the number of A on the top, and then on the bottom is going to be the number of the total, which we call U, okay? This is the total outcomes on the bottom, total outcomes, and that's a number, and on the top you're going to put the number of outcomes in A, whatever A is, okay? And we'll do a couple of examples just to make sure that you understand. So a bag contains 5 red chips, 3 monkeys, and 8 clowns. Interesting bag. What is the probability of choosing a clown, right? So how many clowns are there? There are 8 clowns out of how many altogether? So there are, if you add them up, that's going to be 16. So the probability is going to be 1/2. You can also write it as 0.5 or 50%, right? All of them are exactly the same thing. So these 3 are acceptable answers for this question. Okay? Usually you'll see it as a decimal, 0.5. You have to worry about rounding, but okay. Um, Good. All right. So here are some examples and some more definitions of sample space and events. This is just to kind of like help you. We will go through Venn diagrams in another lesson coming up. So I'm going to skip that part for right now. And then we're going to talk about complementary. Okay. So complementary has a symbol, right? So complementary events are literally look like this, a prime, and what that means is just what is not in A. And in the formula booklet, this is given to you, so the probability of A plus the probability of not A, or A prime, is equal to 1 whole, right? So we'll give you an example right here. So A is the probability that it rains today. So I'm telling you that probability of A is 0.6. So what is the probability of not A? So if we use our formula booklet and we put in the formula that we have, not A, and this should be completely common sense, but P of A is equal to 0.6, so I can put 0.6 here. So to find the probability of not A, that's going to equal 1. So we subtract 0.6 from both sides, right? 0.6. And the probability of not raining is going to be 0.4, because 1 minus 0.6. Good. So that is 40% chance, right? This is 60% chance, just to kind of help you out a little bit. But since they have us writing it as a decimal, you should write your answer as a decimal as well. Okay. All right. The last thing we're going to be doing is something called expected number of occurrences, the expected number that something is going to happen. All right. So repeat an experiment and n number of times, so that the probability of something happen is literally just going to be P of A. And if you continue doing this like a bunch of times, the expected number of times that A is going to happen is you literally do the number and you multiply it by the probability of how many times it should happen. Okay? So that might make more sense in an actual problem. So the probability that a student forgets to bring their calculator to class on a given day is 0.2, right? So you have the probability of calculator and then the probability of not having their calculator. So not having their calculator, they tell us clearly, is going to be 0.2, so that's going to be this number right here. So we need to figure out what this is right here. So remember our formula that we did up, literally just did right here, right? This formula, we're going to go ahead and just use that. Some of you can do this in your head, but 1 minus 0.2 is equal to 0.8. So the probability that they do have their calculator is going to be 0.8. Why did I write POC? 0.8. And again, because they have to add up to one whole. So we're definitely going to use that because it says how many students in a class of 23 would be expected to have their calculators, right? So what we do is we take our n, right, times the probability of having calculators. So how many students do we have here? We have 23 students, and we're going to multiply that by the probability of them having a calculator, which is 0.8. So multiplied by 0.8, and this is going to give us 18.4 students. Okay, so that's how many students out of the 23 would be expected to have their calculators on that day. So this is why we should care about this, right? It's used for predicting the future, when to know what to expect. This happens in like casinos, a lot of different places. Next page is some tree diagrams, and again, we're going to go through a full lesson on tree diagrams. So I just put this here in case you wanted to kind of like get ahead and see where we're going, and then we're going to do a couple of problems using the tree diagrams. So take a look. So the only other thing that I would add to this right here is when you're doing problems, keep in mind that these two numbers, right, have to add up to 1. These two numbers have to add up to 1, and these two numbers have to add up to 1. So this is kind of like a missing piece. So this is 2 out of 5. If 2 out of 5 are orange, then that means that, right, something out of 5 has to be white. What is that number? If they're telling you here that 1/3 is orange, right, then, and this has to add up to 1, then this is going to be something out of 3, right? What number goes here at the top? And then this one right here, you're going to get from the scenario and look back at it, right? So there's 6 white, 4 orange, right? So if you took 1 white from here, there's no longer the combined 10, there's now 9. And if you took 1 white, how many white are left, right? And once you get that, these two have to add up to 1 whole. So that's how you can go ahead and use process of elimination to figure out, and deduction to figure out what numbers go here, and then to answer the question, okay? Give it a shot. We will go over this in class. Look at these notes that are here, and we will go into this into detail.